started. Thanks for that. So we wanted to give folks a chance to get settled and sit down, maybe have their lunch at their desk and enjoy this first of a series of webinars from Data Holdings. We like to understand our customers' applications all the way from the physical layer all the way up to the user experience. So in this webinar, we're going to start at that foundational level where we're talking about the bottom of the stack or the foundation of the physical characteristics that really underpin a business's applications in data center. And then later on in future webinars, we'll move up through the stack and talk about how these pieces of infrastructure are used in your business. If you have any questions at all during this webinar, go ahead and type them into the chat. I love questions. There are no poorly informed questions. I love questions again, so put them in there, and at the very end, I will come through and answer everyone's questions. You'll note that my email's also on the screen there in the lower right. My name's Ryan Brooks, and I am fortunate. I'm the Vice President and General Manager of Data Holdings. We're a public or multi-tenant data center here in Milwaukee, Wisconsin. This was built 10 years ago. We're actually celebrating our 10th year of uninterrupted operations. It was built by the Potawatomi tribe and services the entire region. It's a wonderful thing. I would encourage you to reach out and see a tour, because then you'll be able to check out some of the things I'm talking about today. But today's topic is data center tiers. This is a classification system that, go to the next slide. This is a classification system for people to understand the characteristics of a data center. And like many technical frameworks, this was developed out of a necessity. Previous to the tier system, there was no common language really to discuss, easily discuss characteristics of a data center and what a user of that data center would really experience. So a potential user would have to be very knowledgeable about the characteristics of a data center, HVAC, power, and everything else that goes into a successful data center, ask those questions, and then determine how her applications would operate in that data center, what to expect in terms of downtime. So the tier system's here now, again, out of necessity. It was developed by a company called Uptime Institute. It started in the early 90s. The Uptime Institute's now part of a larger research and consulting firm that provides guidance on data centers, and they actually will come in and certify your data center to a particular tier. They define these minimum requirements for each tier, and again, you'll get a stamp of approval if you pay Uptime Institute for that. So somewhat counterintuitively, keep this in mind during the presentation here, Tier 1 is actually the lowest qualifying tier in the data center world. So Tier 1 is what you would consider the least expensive or the least well-built data center, whereas Tier 4 is the upper echelon of the data center world. Because there's only 4 steps, there's a huge chasm between each steps. So the industry, but not really Uptime Institute, or not Uptime Institute at all, recognizes interim tiers, which we call things like Tier 2 plus or Tier 3 plus. But again, the real goal of these tiers is to closely map how a data center is going to perform to those business needs, so users know what to expect and the business isn't overspending against budget. So let's jump right in. Again, this lowest tier is Tier 1, and this is what we might get in an organization that's self-hosting in a data closet or an extra office. They haven't made any sort of investment in either building an on-premise data center or outsourcing something to a professional data center organization. So they have this extra office or closet. They've placed their servers in a rack. This room was made for human occupancy, right? So it can't really support the cooling and power requirements of servers and storage and networking. They have all their equipment in a rack. They probably have an uninterruptible power supply or UPS. However, in my experience of seeing a lot of these rooms, typically these UPSs aren't maintained well. They have batteries, the batteries go bad, and no one really keeps a good eye on these things, because at the end of the day, no one's responsible for it. And often these UPSs actually cause outages versus preventing them. So they can be an actual source of failure themselves. It would also be very unusual for a building, an office building, to have any sort of resiliency or redundancy or any serious types of physical security controls to keep the right people in and the wrong people out. The first big jump here is up to tier 2. And again, each one of these tier steps, because there's only 4, represents a really big increase in expense and complexity. Most data centers in the world fall into the tier 2 category, and that includes data centers that host individual organizations or multi-tenant data centers like our data centers, where anyone with an interest can come into the data center, sign a contract, and occupy space. At tier 2, you still have a single power feed from the utility, meaning that that power feed, when it goes down, we're in an emergency state. There'll be a commercial UPS system that is well maintained, where the batteries are replaced, and that will protect against short power outages. And typically you'll have a generator, probably only one, but you will have a generator that will come online, so the UPS only has to run for a short amount of time. These tier 2 data centers represent a significant upgrade over self-hosting, having something in a closet. Let me tell you, as we go around and talk to customers anywhere in the country, people have some pretty interesting on-premise data closets and things that look like, well, they look like a plate of spaghetti, and it's not good. So when you come into a tier 2 data center, the uptime increases dramatically, and the physical security increases dramatically. However, these T2 data centers or tier 2 data centers have a lot of exposure during maintenance activities, when the data center is doing expansion or bringing in another customer, when they're doing testing, or maybe they don't do testing, and weather events. A strong wind, storm, that can impact the performance of a tier 2 data center and create application downtime. The biggest leap in the tier system is really tier 2 to tier 3. And in this tier 3 world, these are significantly more costly to build and maintain than a tier 2. These are almost always a custom building that was purpose-built and designed by a professional engineering organization. It's not a repurposed building, because those repurposed buildings usually cannot meet the requirements of the uptime that the customer wants to see. It's important to remember that when you're in something like tier 3, if you have one characteristic that's tier 2, you get bumped down to that tier 2 level. So you have to meet all the minimum requirements to be at a certain tier. So the professional engineering organization would be involved in making sure that there are no gaps in that regard that would bump you down to a lower tier. In the case of a tier 3 data center versus a tier 2, when preventative maintenance work is done, when there's a weather event, none of that is going to decrease the availability of the data center or even increase the risk to its tenants. To make all this happen, there's always extra capacity sitting around. This is what makes it so expensive, right? You have, it's expressed in the term of in, or the requirement or need, +1. So there's always spare cooling, spare power, spare connectivity sitting there unused, which is essentially an investment made by the data center operator or data center builder that will never generate revenue, but it's sitting there to make sure that it can support customer load during any sort of emergency. So that sort of stranded investment is there, it's substantial, and this applies to every piece of infrastructure in the data center, but particularly power and cooling. That's the lifeblood of a data center. The power must stay on, the servers must stay cool. All these systems are also dual powered all the time, so they're redundant within themselves and they can fail over. And the reason I say it's such a big leap is because the experience that the application or users will have for something hosted by the data center is going to be so much better than a tier 2 data center. The expected downtime per year goes down dramatically. The last tier, or the most sort of upper echelon of the tier system, is tier 4. This is absolutely the pinnacle of the industry. The leap isn't as great in terms of performance as tier 2 to tier 3, but it's huge in terms of cost. So going back to that N+1 statement for the need or requirement plus additional, tier 4 always has twice or 3 times, in many cases, the need. So every path, every wire, every power wire, network cable, fiber has a diverse path, cooling has a diverse path, diverse systems. These are physically diverse and also administratively diverse to avoid human error. So with Tier 4, even with unanticipated events, huge weather events, huge maintenance, or maintenance that's gone wrong, I should say, in Tier 4, there won't be an impact to the customer. These Tier 4 sites are very rare. They come from a past of mainframe type operations. So there's only 3 in the continental United States, at least as of this webinar date, so around August 2023, and only 1 of those is multi-tenant. So it's a very expensive proposition. And again, what people found was it's easier to build applications, or actually less expensive to build applications and spread them across regions, across multiple data centers, than to build one perfect data center to eke out that last little bit of uptime out of the data center itself. So again, think old mainframe applications, things that are fragile and have to be up and don't easily replicate. That's the target for Tier 4. So those are the tiers in the Uptime Institute tier system. Here at Data Holdings, we consider ourselves Tier 3 plus because we are a Tier 3 facility. We meet all those requirements, but we have Tier 4 characteristics for power. So it's a wonderful facility, and I think it's just incredibly cool that it's in our backyard and here in Milwaukee, Wisconsin. So if you're watching this, you may be considering moving into a data center. So we wanted to list some of the questions that outside the tier system that we thought you might want to consider. So again, the goal here is to match real business requirements. So capture those first, have an application inventory, understand what can be tolerated in terms of downtime, and then pick an appropriate data center that fits the budget. You don't want to overspend, and you want to have something that doesn't impact revenue at the end of the day, that keeps your users or customers happy. So in addition to considering the tiers, here's some other things that we think you should consider. Oop, pop back a slide. Make sure the building is purpose-built, right? So was it designed from day one for the power and cooling loads that computers required, that it wasn't built for humans? Something built for humans has an entirely different power profile than a building built for servers. They say a human has a power load of about 100 watts for HVAC. Well, a server could be a kilowatt or 1,000 watts. So a little server could be like 10 people in a small room, right? So it's a whole different set of math and requirements for that server, and also the physical security. Another thing that doesn't come up in the tier system is how the external connectivity comes into the data center. And you can see this visually even from outside a data center. And by this, I mean aerial delivery of power and network on a telephone pole or underground. So on an aerial system, it's inexpensive compared to underground by a factor of about 5. However, the downtime you experience on aerial versus underground is about a 9x difference. So it's 9 times less likely to have an outage if things are delivered underground. And there's also physical security associated with that as well, where you might come in via vaults in the street to protect those very important, again, lifeblood of the data center, connectivity, power, and cooling. From a physical security standpoint, is there a buffer between the road or access to the data center and the actual edge of the building? You don't want a car or truck to be able to hit the data center. You don't want people to be looking in windows. There shouldn't be windows in a data center. So is there a gate or a fence or wall around the data center to keep people out? Another thing to consider that is beyond just the physical layer is really the latency that your users will experience. So some applications are very sensitive to latency. So some applications need to be very near their users or near the database that's running the applications. Or in the case of enterprise, you may have a replication strategy that requires you meet a latency requirement. So location may be very important. Is the data center 24/7? Some tier 2 data centers simply aren't manned all the time. So you show up, you might be the only one there. And then lastly, what are the risks around the area of your data center? Is there a lake next door? Is there a rail system? Are there freeways right there that there could be a fire and impact your data center? And again, a combination of things can remediate that, including underground delivery, but let's just eliminate those risks to begin with. I wanted to capture some of the questions. So we do a lot of data center tours, and I wanted to capture some of the more interesting questions that have come up by during tours. One is, so You have a UPS that protects you against a power outage. Then you have generators that come online after that if the power outage is extended. So what's the refueling strategy? How long can that data center survive and keep the lights on, keep the servers running, keep the cooling running without any external power from the power provider, from the power company? So how long can that site run on generator power? How do they get more fuel during an emergency? Another one that we get asked a lot are what compliance frameworks has the data center had attestation for? So we do several here, and two of the most popular are SOC 2 Type 2 and PCI. So this is when a third-party auditing firm comes in and makes sure that we say we're doing the things in our contract. So it's not just us saying, hey, we're doing these things, we're doing our preventative maintenance, we're keeping the right people out, or keeping the right people in and the wrong people out. So have a third party that will attest, like an accounting firm that says you're doing what you say you're doing. On the data center floor, hopefully it's raised floor. Again, you need raised floor to support a lot of these applications, especially with AI coming down the pike now. Do they adhere to ASHRAE standards? That's a cooling and environmental standard. Do they even know what that is, and do they adhere to it? Ask them about the last outage they had. What was it like? Maybe they didn't have one. Maybe they had a post-mortem that they could talk to you about. What were their learnings from that last experience? How does the building do during weather? Again, this is something that comes into play when you see light industrial or data centers built in light industrial or office buildings. It might not be built to really survive things, or it might have windows into the data center space, right? So how does it survive a storm? What's the storm rating? Are there other tenants? If it's a multi-tenant building and not just completely dedicated for data center, what are those other tenants doing? Are they doing manufacturing where there's a risk of fire or something that would create other risks to your business, even people coming and going? Again, was that building purpose-built? Grounding is something else that comes in with a purpose-built building. You should see interior grounding, big copper bus bars and big green ground wires. There should be grounding on their fuel supply. There should be grounding on the building. You should be able to see all those things during a tour. But that's very important, something that you see with a purpose-built facility. What kind of tests do they do? So you never want anything to be a surprise. So you can do something called a load bank test, where you're really simulating a complete failure of electrical power. You're not again, in a tier 3 facility, you're not impacting availability, you're not creating risk for users, but you're really testing out operations and the preventative maintenance you've done on your generation and UPS gear and cooling to make sure that the data center can continue to operate in an emergency. And then the last one, this has come up a lot because there's a lot of pressure for consolidation in this industry. How many times has the facility been sold in the last, say, decade? You can create technical debt when this happens. So you might have different staff that comes in, they don't know the nuances of the building. Technical debt is another form of risk. And what should you, if it's changing hands a lot and going into bigger and bigger companies and there's lots of employee turnover, what does that look like? What will the experience be like at that data center? So that is kind of an overview of some of the things to consider when picking a data center, and also just a really brief overview of the tier system. We want to lay the foundation in this discussion so we could get into what I think are more interesting things when we get higher up and closer to the users. But here's what I would say if there's a couple of takeaways. Get a tour. Ask for a tour if you're considering a data center. It's absolutely fantastic. It's very interesting. Don't be afraid to ask questions. People see interesting things when they tour, and I've toured a lot of data centers and also given a lot of tours, so ask questions. Also consider, hey, you're talking to a human being. What are those other people like in the operations staff? You'll meet them when you come in and they check you into the data center. Those people may be intimately involved in helping you survive an outage, helping you if you declare some type of disaster, there's a business continuity test even, they might be involved in that. So what does that look like? And then, is it local, right? If you're working with those local people during either normal operations or even a disaster, can you drive there? There's a joke that's been around for years that talks about it's hard to beat a station wagon full of tapes in terms of bandwidth. Well, we don't use too many tapes anymore, but we don't have too many station wagons, but it's hard to deny the latency advantages, and also knowing of being local and also having local partners and you know their names, and being able to get support from a human being versus just a web portal. Being able to go to a site, pick up a server or bring a server, and having it within a 15-minute drive is really, it's hard to quantify that, but it can be a big impact to time to restoration when you're working with human beings. So let me check the chat for any questions. Anybody have any questions at all? One moment here. Okay, I'm pausing the recording so we can edit, right? I'm paused.
Oh, okay.
Yeah.
Are you sent some questions and have you seen them?
No, I'm in the chat too. Oh, questions, because it goes into questions. Okay. All right, sorry about that, folks. I was looking in the wrong area. You guys, everybody can hear me, it looks like. So what can I expect in terms of downtime with the various tiers? Tier 4 almost gets you to 5 nines of downtime. I have an extra slide. 1 second, let me get it up here. We're really talking tier 3, tier 4 here. Tier 3, you can expect, here's some numbers here too, and if someone wants to email me, I can share this, but tier 2, you're looking at less than about an hour and a half of downtime a year. I know here at Data Holdings, we're tier 3 plus, and we have never actually had a power or cooling outage. So we're running at 100%, but these are numbers based on, you know, the tier standards, what they feel you can achieve statistically. So hopefully that answers that question. Cost difference between data center tiers. Tier 1 is completely DIY and may not involve a recurring cost except for cooling and power, which I suppose can be substantial. It depends very much on the geography, what tier 2 and tier 3 looks like. Usually there's not a ton of difference in cost to the end user. At least that's what I'm seeing. Tier 2s sometimes can be a little mom and poppy, for lack of a better term, where tier 3s are a little more professional and have economies of scale. So I don't see a big difference in cost for choosing between tier 2 and tier 3. Tier 4 is a whole nother story. Usually people are building those. And here's a relevant question to tier 4. Are there tier 4 data centers and where are they? Yeah, so there's, as of August 2023, when we're doing this webinar, there are 3 certified design and built tier 4 data centers in the continental US. Only one of those is multi-tenant, meaning it's a commercial data center that you can get into, and that's outside of Las Vegas. It's very well built, huge investment. They mainly sell large bays, so think, you know, I need tens of thousands of square feet, not a single rack. And then the other ones are an insurance company and a bank. So again, it skews toward finance because the mainframe era, with the advent of virtualization and cloud and things, people go multi-region versus really going for tier 4. So I don't think we're going to see too many. I don't think anyone's going to make a tier 4 investment anymore. Here's one. What type of companies move into a tier 4 data center? That I think I got that, which was largely legacy finance and insurance verticals, I would say, but not new. So like even if you were finance and you were building a banking app, you would build that across regions and multiple data centers, and you wouldn't go after tier 4, but some legacy backend equipment might be in a tier 4 that you build yourself. Thank you for this one. Why would I pick Data Holdings over another data center? Well, come by and see us. We're very passionate about it. I love this data center. I'm a Wisconsin native, and it was a really big investment here in the state by the tribe, and it's really cool. It's something that you would see in a really a top city in the US, but it's here in our backyard in Milwaukee. And I think it's really cool. So you can take advantage of a very large investment by the Potawatomi tribe, have a really great uptime experience. We're carrier neutral, so we don't care what carrier you want to use, meaning what connectivity to the outside world. We want to create a competitive environment. We have a lot of services here. There's a lot of managed service providers already here. We have a great record, and I think if you came out for a tour, you'd see a lot of our benefits. So come by for a tour, and I think that just seeing what we have here, it would be really cool. So thank you for that question. And I think that's it. So 1 month from now, we're going to do another one of these, and we're going to talk about a little bit about public cloud, how it's impacted us, what the public cloud providers are doing. And just thank you for listening to our talk here. I realize physical layer isn't the most interesting thing in the world, but I'm pretty passionate about it. So thank you for listening. And again, I'll put my email, get my email back up on the screen. And if you have any questions or want some help with something, again, I'm not a sales guy, so you can just send me a question. We won't bug you. It's just Ryan Brooks at rbrooks@dataholdings.com. So thanks so much, and thanks for spending your lunch with us. Bye-bye.